Everyone, welcome to Josh Max channel. In this video, we are going to see for CBSE Maths Grade 12 Standard Chapter 5 Continuity and Differentiability in Exercise 5.1 25th sum. Already in the last videos, I have uploaded solutions till 24 sums from this exercise. So please do check it. Now let's start with the 25th sum. Now examine the continuity of f where f is defined by here f of x is given sin x minus cos x if x not equal to 0 minus 1 if x equal to 0. So here they're asking us to examine the continuity for the f of x, right, throughout the real line. So here what point we are supposed to check that the indicated point is not given. So we have to understand throughout the real line we are supposed to check the we are supposed to examine the continuity. Okay, so here using the if condition, what I'm going to do is I'm going to break the real line. Okay, so minus into positive infinite, let this be the real line. Now using this if condition, I'm going to break the real line. Okay, now we can see the two intervals. Okay, this interval also x is less than 0 and here is x is greater than 0, but both are x not equal to 0 only, right? Okay, so we don't have a different functions for if x is less than 0, if x is greater than 0, we don't have functions. The available functions are if x is 0 or if x is not equal to 0. So based on the given condition, we are supposed to take the cases. Okay, if x is not equal to 0 will be one of the case, and other case will be if x is exactly 0. That means for this particular sum we are going to have only the two cases, and to check the continuity for the any function we need three things. Okay, suppose if you are checking the continuity for at x equal to 0 for the function, what are the things are required? F of 0 is required, left hand limit is required, and right hand limit is required. If all these three values are same, then we can say function is continuous. Okay, so let's start with the case 1, if x is exactly 0. Case 1, if x is exactly 0. Okay, if x is exactly 0, what we need to find out first? F of 0 value. Okay, now let's substitute in place of x as a 0. What is the suitable function here? If x takes the exactly 0, what is the given? From the given, f of x will be minus 1. Okay, now left hand limit, right hand limit we have to find out. And left side closed values of 0 are approximately 0, but those values are not equal to 0. Okay, and right side closed values also approximately 0, but those values are not equal to 0. So since for the left hand limit and for right hand limit we have only the one function to deal with, so instead of finding it separately, I'm going to do it together. Okay, so now limit x is approaching to 0 from both the sides. Okay, for both left hand limit and right hand limit together I am doing it. Now f of x, so what is the suitable function? Both the sides approximate values are not equal to 0. So suitable function is the first one, sin x minus cos x. Now apply in place of f of x as a sin x minus cos x. Okay, so after replacing, what we are going to do, we are going to apply the limit. Now in place of x as a 0, now sin 0 minus cos 0. Sin 0 gives you 0, cos 0 value what? 1. So here we have a minus sign and 1. So 0 minus 1 is what? Minus 1. Now from these two results, what we can say here, f of 0 value and left hand limit, right hand limit together, what is that? Limit x is approaching to 0, f of x both are same, no? So we can say that given f of x is continuous, what is the point that we have taken? X equal to 0. So continuous if x is exactly 0. Okay, so the question is demanding us to check the continuity throughout the real line. So as of now, only for one real value only we found. Okay, for other way, all real values are x is not equal to 0. In case 2, we are going to check. Okay, now in case 2, what is the condition that we are going to take? If x is not equal to 0. Okay, now throughout the real line, if x is not equal to 0, how many real values we have? Infinite real values? No. Okay, so for that, in common, I'm going to have a name. Let C be the any real value. Okay, let C be the any real value. At the same time, what is the condition I have taken? Not equal to 0. So C be any real value and C is not equal to 0. Okay, now let's take C is here somewhere. Okay, now to check the continuity for the C, what are the things are required? F of C is required, left hand limit and right hand limit is required. Now let's find out for the f of C. Okay, so when we substitute in place of what is the C? C is not equal to 0. What is the suitable function? First function. Now I'm going to replace x as a C, no? Then what is the given function? First function sin x minus cos x. That means sin c minus cos c. Okay. Now limit. Now limit x is approaching to c, and remember the both the sides of the c are approximately c. C itself not equal to 0, and close values also obviously not equal to 0. So what we can do, the for left hand limit and right hand limit, suitable function is first function only, right? So instead of finding left hand limit, right hand limit separately, together I can combine and we can find out. Okay, so limit x is approaching to c, f of x. What is the suitable f of x? The first one, no? So replacing f of x with the first function, that is sin x minus cos x. Now applying the limit, what happens? We know that difference of two continuous functions are continuous. So already we know that sin x is a continuous function, cos x is a continuous function. In which sum we have seen this part, I think 22nd sum. Yeah, discuss the continuity of the cosine, cosecant, secant, cotangent. While working out this sum, first we proved that sine and cosine are continuous. With those result only, remaining trigonometric functions we said it are continuous. So anyway, so here I will upload. I'll give the link for this 22nd sum as well. So please do check it below the description. Okay, now let's continue. So we know that already sin x and cos x are continuous function. Then obviously at any value, no, so sin c minus cos x also, surely it will be continuous only. Okay, even you can write the statement, but you can see f of c and these values are same only. So with this result itself we can say that f of c equal to limit x is approaching to c, f of x is both are same. Okay, so now what we can say here, f of x is continuous for all real values. Okay, first for the case 2 I'll write continuous for if x is not equal to 0. From both the cases, what we can conclude from both the cases, f of x is continuous for all real values. Okay, and do remember all trigonometric functions are always continuous. Okay, in its domain. Now they have given sin x minus cos x, right? The difference of two continuous functions also continuous. So that even we can say it in that way instead of proving this. Okay, now thank you for watching and please do subscribe. Thank you.